Welcome to Algebra 2, Lesson 6-4, Rewrite Exponential Expressions. Today's date is Monday, December 7th, 2020. We've got exactly a week until finals. Oh boy. Everyone, please have your cameras on so I can say hi to your beautiful faces and make sure I can see more than just your forehead, because that would be nice too. So Jenny, Josie, Jessica, throw up kid, who are you? Everyone make sure your cameras are on. Thank you. All right, our objective today with a quiet raised hand is to someone, please, someone. Jade.
I wanted to read it. Oh, I get to read it? Use properties of exponents to rewrite exponential expressions.
There it is, our first key step of a future hard process. So, okay, example number one. What is the value of a when we rewrite 2 to the power of x minus 7 plus 2 to the power of x? And I need to rewrite it as kind of like factoring out a 2 to the power of x. What is the thing that I need to factor out to just be left with 2 to the power of x? And when I first look at that problem, I have no idea what to do. Like, how is it? You can't factor anything out of 2 to the power of x minus 7. That's just one expression. There's like some exponents up here. I must have to use a property of exponents to manipulate this so that I can factor something out. Again, remember, factor something out if you have like a 2x squared plus 3x, you say, oh, you can factor out an x. If you factor out an x, you're left with x to the power of, or x times 2 to the power of x plus 3. That's factoring out an x. We're factoring out a 2 to the power of x. That's what the problem wants from us. And it's asking, well, what's left over? What's this leftover piece after we factor out the x? It tells us what the greatest common factor is already. So our first challenge is, how do we rewrite 2 to the power of x minus 7 as something times something else? I want to say this 2 to the power, that's our first step. 2 to the power of x minus 7. I want that as something times something else, because if something times something else, I'm allowed to factor out. And if you are clever and you remember your rules of exponents, your rules of exponents state, oh yeah, things are subtracted, this subtraction rule, with two rules put together.
Mr. Sindel, I gotta go.
Yes. Okay, sounds good. Just watch the video.
Okay. Where is it gonna be?
It'll
On the
be on
website?
the website.
Okay.
Yep.
Thank you. Bye.
Yeah, you're welcome. And there is maybe a shortcutty way to do this too. So let me show you guys the shortcutty way, because this is adding like 2 unnecessary steps, and I can make this a little bit shorter. But this is, I just want to make sure everyone kind of has this general idea of we need to somehow factor something out. So let's go ahead and actually do the factoring, because it saves us some time. So if I factor out 2 to the power of x out of these two terms, 2 to the power of x, I'll just rewrite this as 2 to the power of x, or sorry, 2 to the power of x minus 7. I'm gonna have to do something extra here. Let me get rid of this box, it's too big. Let me rewrite this. I still have 2 to the power of x minus 7. I have to somehow do something here to make this work. Plus 2 to the power of x. Here's my trick for you guys. So my trick is, if I factor out a 2 to the power of x, to make this expression right here the same as our initial expression, I need to, if I'm going to be factoring out a power of x, I need to be factoring in a power of x over here to keep everything balanced. So let me show it, and then I'll explain it after I do that. So really what I'm doing here is I need to subtract a power of x. If I've added a power of x over here by factoring out, I need to take it away over here, which means I also need to take it away right here. If I were to factor it out, and you please don't write this if you're actually taking notes. If I were to write this out and multiply this back in, I would say, okay, x, let's just look at this first term, 2 to the power of x times 2 to the power of x minus 7 minus x. I'm just multiplying our first term, or our greatest common factor really, times this first term in the parentheses. I'm just doing that step right here. I'm going to do the second step maybe in a little bit, but look what happens. This is really saying 2 to the power of x, and then I'm going to be adding that x with this x, and they're going to cancel each other out. I'm just left with x minus 7. This x right here, let me do it in a different color. This x and this x cancel each other out, and I'm left with just 2 to the power of x minus 7. What I'm showing you right here is that, I'll leave that cancel out. These two things multiplied by each other is the same thing as 2 to the power of x minus 7. I've proven it by showing you right here. If I actually multiply them back through, I still have 2 to the power of x minus 7. So if I had to condense this rule, this trick into one simple statement, I would say, go ahead and factor it out like it's asking you to, but because I'm factoring out, subtract a power of x into each of these terms. If I have to factor out 3 to the power of x, well, this is a slightly different problem. There's a bunch of different tricks I'm going to try to get through today. But if I just need to factor something out, go ahead and factor it out. But remember, if you're factoring it out, make sure that you're subtracting a power, because you're really dividing by 2 to the power of x, which is the same thing as subtracting by that power. I have no idea if you guys are following me. I just get blank stares, so I have to do the fist of 5. Am I talking nonsense? Am I at a 1? Am I at a, oh yeah, that makes perfect sense, at a 5. I'm at a 2 for Jade. I'm at a 2 for Fernando, a 3 for Wyatt, a 3 for Andres, a 1 for Jenny. Yeah, these are hard too. So let's think of a different approach. I would say our average is probably beneath a 2, which is not good. Let's think of this as a different way. And I've never tried this second approach before. So if I fail even more completely, I apologize. I haven't tried it this way before. Let me try actually doing the factoring. Let me try doing it the long way. So really what I have here is 2 to the power of x times 2 to the power of negative 7. Let's just pause and think about that. 2 to the power of x times 2 to the power of negative 7. What I'm invoking here is I'm invoking this rule that states if I have, in reverse too, if I have 2 to the power of a plus b, this is the same thing as 2 to the power of a times 2 to the power of b. But because there's a minus sign, I just move the minus sign over here. Okay, let's just do baby steps. On that first step, fist of 5, how well do you guys understand why 2 to the power of x minus 7 is 2 to the power of x times 2 to the power of negative 7? Okay, I'm getting higher scores. I'm getting 5s, 5s. If you don't know, you need to put up a 1 or a 2 so I can pause and re-explain this. Everyone's giving me 4s and 5s. Cohen is at a 4 maybe, or maybe he's just touching his head. I don't know. It looks like I'm getting much higher scores. Okay, so I can rewrite that one this way. So let me get rid of all this junk down here because that was the confusing bit. I can also, this is kind of silly to do, but I think it'll help us. 2 to the power of x is 2 to the power of x times 1. That should be like a 5 for everyone. Like that's silly, Mr. Sin. Why are you showing us that? I'm showing you that because what I'm about to do is I'm going to now factor out a 2 to the power of x out of both of these two terms, and what is left over is this. So if I factor out now, I'm looking at our original expression. I'm factoring out a 2 to the power of x. That's what the question was originally asking us to do. Let me get rid of this circle. I'm factoring out this 2 to the power of x, so let's do it. If I factor out 2 to the power of x, 2 to the power of x, what's left over is 2 to the negative 7, 2 to the negative 7 times, or sorry, plus. No, it should be, what am I saying here? Okay, yeah, there's a plus sign here. That's where the plus came from. I was confused there for a sec. Plus 1. And we're basically done. So this is our intermediate step right here, knowing how to get a 2 to the power of x factored out of each of these two terms. How do I get rid of 2 to the power of x? Oh, well, I'm left over with 2 to the negative 7. How do I get rid of 2 to the power of x? Well, that gets rid of everything. So 2 to the power of x divided by 2 to the power of x is 1. So hopefully you're now able to connect, oh yes, we have indeed factored out a 2 to the power of x. So give me a fist of 5. How, on this next baby step, how well do you understand this factoring step? Did I lose people? Okay, I'm still getting 4s. Like Cohen, Sergio, Josie, people with their cameras off. I don't know how you're doing. I'm at 4s, okay. Okay, and then we're done. Because look, this is our A term. This right here is our A term. Because I have something, it happens to be a bunch of 2 to the power of negative 7 plus 1, something times 2 to the power of x. And that's what this is saying. Something times 2 to the power of x. And what is this something? Well, that something is, I have to figure this out now. This is like the scratch work over here. Well, A is 1 plus 2 to the negative 7. I just switched the order there. And you can actually figure out what that is. So, and I think I need a bit of room. So let me, is it gonna let me select things? Select things, thank you. I'm gonna move this up here. What is A? Doing a little bit of math to figure out what A is. This is equal to 1 plus 1 over 2 to the power of 7. I'm just using one of our rules of exponents that states when I have a negative power, flip it and make it positive. So I flipped it. It used to be over 1, right? I flipped it, and the one's on top, and I have a 7 in the for power in the denominator that's positive. And then I'm about to do some math magic for you guys, and I feel bad. This lesson is mainly me talking, but it's really hard, and it's long to like get through. So I unfortunately have to do most of the talking. Well, I need to combine like terms. I have to actually add these because you can't enter in Khan Academy 1 plus 1 over 2 to the power of 7. You actually have to enter one fraction. So how do you boil this down to one fraction? And maybe someone can do that. This is like the easier piece. Yeah, what?
Well, wouldn't you want to know what 2 to the power of 7 is?
That would help us immensely. What is that?
Would that be 512?
Ooh, really close. You're off. That would be 2 to the power of 9. 2 to the power of 7, I think is just 128. But let me check. 2 to the power of 7. Yeah, it's just 128.
Okay.
So I can say this is really 1 plus 1 over 128. But how do I add those together? Any ideas? Wyatt's already boiled it down to 1 over 128. How do I add fractions? Go all the way back to, I don't know, 3rd grade. When did you learn how to do this? 4th grade? Sergio, do you have an idea?
So you do like 1 over 1.
Yeah, this is gonna be 1 over 1, but to have a like denominator, I can do even a bigger number over.
Do like times 128.
Exactly, so you'll have 128 over 128, which is 1 minus 1 over 128 for a final answer of, oh, what's going on, what?
Teacher error, you said minus 128.
What am I doing? Yes, log it, extra credit. I randomly changed the plus sign into a minus sign. Our final answer here, do it in red here, is 129 over 128. Okay, so that is one of 4 tricks that you'll be using, one of 4 types of problems that you'll be seeing tonight. We have one homework assignment tonight, and it has all these tricks that it's trying to test you on. This is one of them. How do you factor things out using rules of exponents? And then once you factor that out, because we already had that part, then we had to do the second half of the problem over here of how do we boil that down into one number. Okay, so fist of 5 on example 1 before I move on to example 2. 3s and 4s, Sergio's at a 2, Cohen's at a 4, Josie's at a 4. Okay, well, I say our average there is a little above a 3. Okay, example number 2. So this one is an entirely different problem. What is the value of A when I rewrite 3 to the power of x as A, which could be any number, to the power of 7x? And again, it's one of those questions where if you haven't seen it before, you're scratching your head like, what is it even talking about? Like, what? Okay, so I obviously have to have a change of base. It's not a 3 anymore, because if it was a 3, that doesn't make sense. What base do I choose so that I can have a power of 7x? And basically, you need these two things to equal one another. 3 to the power of x is going to turn into a to the power of 7x. Those are equal to one another, so we might as well start off by saying they're equal to one another. 3 to the power of x is equal to a to the power of 7x. They have to be equal to one another. So what I'm going to be focusing now is that right-hand side. That is the general form that I want to get to. That is my goal, get to this form. I'm going to manipulate the left-hand side to try to make it look like that. How do I manipulate the left-hand side? Well, I want a power of 7x. So let's make it to the power of 7x. I can't just magically do that. You'll have to undo something that I'm doing. If I do that, I'll have 3 to the power of 7x. Perfect. But I need to also take this to the power, like that 7x, yummy, I want that. But I also have to get rid of a power of 7. Is there any way to get rid of a power at the same time as doing a power? And it's not that hard of a trick. Jose?
I'm gonna say you're gonna divide it by something.
Divided by the thing that we multiply by. Yeah, if I multiply by 7, divide by 7, right? So to the power of 1/7. So I got that 7x, but I also have this random to the power of 1/7, and I'm basically done. So this is still equal to a to the power of 7x. I'm going to rewrite this left-hand side to, you're allowed to switch the inside and outside just because they're being multiplied. Whenever I have a power to a power, really you're saying 7x times 1/7, which is again just x. So what I'm going to rewrite down here is, let's use blue, new color. 3 to the power of 1/7, that is on the inside, and this is going to be to the power of 7x. That should be equal to a to the power of 7x. Notice that I'm just rewriting that right-hand side over and over. That hasn't changed. But look at what I have on the left-hand side. I think everyone can, if you just stared only at this left-hand side of the equation, 3 to the power of 1/7 to the power of 7x, you'd say, oh yeah, you multiply 1/7 times 7x, and those would cancel each other out. The 1/7 and 7th would be gone, and then you'd just be left with 3 to the power of x, which is what we started with. But even better yet is this. Go ahead and just kind of do a square around 3 to the power of 1/7. That is just a number. And what number is that? That is the number a. If I rewrite 3 to the power of 1/7 and kind of cross it all off and just say a to the power of 7x, well, that's a to the power of 7x. We have figured out what a is. A is 3 to the power of 1/7. And we have solved it. Yeah, question, what?
Why is it 3 to the power of 1/7 though?
Can you ask a more specific question, because you're kind of
I
asking me
just don't
this.
understand why 3 to the power of 1/7 is a.
Because if I rewrite 3 to the power of 1/7 as a, then this left-hand side looks like, instead of 3 to the power of 1/7, I wrote a, and then I rewrite whatever's left over, 7x, which is
Okay.
exactly the form that they're trying to ask us for. How do I rewrite 3 to the power of x as a to the power of 7x? That only works if a is 3 to the power of 1/7.
Okay.
And then again, how do you enter this into Khan Academy? Khan Academy doesn't let you, it might let you do fractional powers. I'm not 100% sure about this, but you can rewrite this also as something else. You can say a, obviously we started off with 3 to the power of 1/7. I'm just rewriting what we did over here on the left-hand side, but you can rewrite this in radical form with a square root. Well, it's not a square root, it's a 7th root. And I kind of gave it away, but can someone else help me? How do I rewrite this in radical form? Right now it's an exponential form with a rational exponent. Can someone help me use this radical symbol to tell me how to rewrite this? I've been calling Wyatt and Jose a lot. Is there anyone else that could do it? Sorry, Wyatt and Jose. This is just review from like 6-1. Yeah, Andres?
Is it gonna be the 7th root of 8? I mean 3, not 8, not 3.
Yeah, 3. Exactly, yeah. 7th root of 3. There it is. So I think this is probably how you'd enter it on Khan Academy, although you might be able to enter 3 to the power of 1/7. I'm not 100% sure. All right, cool. So that's the second type of problem that you might encounter. Give me a fist of 5 on example number 2. 4, 4, 3, 3, 4, 3, 4, 3, 4. Okay, average about 3.5-ish. Thank you guys. All right. So I feel kind of guilty for saying this, but example 1 and example 2 are kind of like the medium level difficulty. Example 3 and example 4 are like we're full spectrum. I'm turning the dial all the way to 11 right now. Here we go. What is the value of f of x? That's what we're trying to find. So what is this thing right here when I rewrite all of this as just 1/2 to the power of f of x? So I'm going to use some tricks that I've used before in example 1 and example 2 to help me out here. Really, it's just coming from your rules of exponents, your properties of exponents. So I'll let you guys look at this problem for a little bit. There is a few first steps that you could take. Anyone have an idea of where we should start? Question from Wyatt.
Well, it's kind of like an answer of where we would start, but I'm asking you, shouldn't we like write the expression first, so we know what we're talking about,
Write the expression first. What do you mean by the expression?
or like the equation?
Okay, yeah, so just set them, like instead of having an as, have an equal to sign right here.
Yeah.
That's a perfect first step. Let's do it. So, all right. And there's going to be a lot of steps. So if you have my notes with you, you might want to start squeezing them in. I think I'm going to go down and then back up. So 1/16 power of x times 1/2 to the power of 7x plus 2 is going to be equal to 1/2 to the power of, I don't know, I kind of am tired of writing f of x, maybe question mark. Question mark is what we're really trying to solve for. If we solve for question mark, we have our answer. All right. So good first step. What should we do next? Yeah, Sergio?
Can you like for 1/2? Can you do like times 8 to?
To get like denominators?
Yeah.
You're close. You're on the right track. Somehow you want to get these the same, but you're going to be using, I think it's like less than 6-3. What was the one where you said higher powers? 16 can be rewritten with a base of 2. Go the other way. Instead of having everything a base of 16, have everything a base of 2, because this is already a base of 2. This is already a base of 2. 16 is 2 to some power. 2 to what power is 16 though? Andreas, 2 to what power is 16?
Would it be to the power of 3?
2 to the power of 3 is 8. Multiply by 2 again.
Okay, 4. Yeah, it's 4.
So we'll rewrite this 1/2 to the power of 4. All that still to the power of x times 1/2 7x plus 2 for the power, and still 1/2 to the power of question mark. Cool. So now we have almost the same basis. I actually have to pull out this 4. How do I do that? How do I pull this 4 out to this exponent? Is it going to be x plus 4? Is it going to be 4x, x over 4, 4 over x? Somehow get that 4 not on the inside, on the outside. I just want 1/2 on the inside. What do I do? Jade?
You'll have 1/2 to the power of x, or yeah, 1/2 to the power of x minus 1/4. I think. I don't know. I think.
Okay, how'd you get that?
So the 4 is on the inside. So you want to take it out. So then you convert the sign and make it into a negative. But
Yeah, so you'll have
yeah.
-4 on the top. Okay, I see. So that only applies if you're moving the entire exponent. So you can rewrite this as 2 to the power of -4. But if you have 2 to the power of -4 instead of a half, then all of these are going to have to change as well, which is okay. But I think there might be an easier way of leaving it in the denominator, because otherwise our base is now going to be 2 instead of 1/2. We kind of like the base of 1/2. So I think I see where you're going, but there's a slightly different path that's easier. Wyatt?
So if so x is to the 2 to the power 4, 1 over to 2 to the power 4 to the power of x, isn't that 2 exponents? So wouldn't you multiply, so it'd be 1/2 to the power of 4x?
Yeah, and I'll do both of those steps just so that everyone else can see it too. So 1 over 2 to the power 4 is the same thing as 1 over 2 to the power 4. Why? Because this 4 really gets distributed. I'm putting like air quotes around distribute. So it's really 1 to the power 4 over 2 to the power 4. 1 to the power 4 is still the 1. And then 2 to the power 4, well, there it is. There's 2 to the power 4. So what we're really doing is kind of like undoing of that rule. We're factoring out of 4. So it's really 1 over 2 to the power of 4. Oop. And then Command Shift C, does that not? Oh, there it goes. And then from there, that thing is still to the power of x, which is why it says, okay, well, now I have a power to a power. You're multiplying those powers and you get 1/2 to the power of 4x. So I'm going to rewrite this intermediate step just so that everyone can follow along our notes. This is still times 1/2. Nothing else has changed. We've only been working on this piece right here. Everything else is the same. 7x plus 2 is equal to 1/2 to the power of question mark. And then I'm going to do Wyatt's step, and he told us that this should be 1/2 now to the power of 4x times 1/2 to the power of 7x plus 2 is equal to 1/2 to the power of question mark. Okay, and then we're really, really close now. Now we have the same bases. We should be able to combine both of these two pieces into just 1/2 to the power of 1 exponent. Who can do that for us? When I multiply the bases, what do I do with their exponents? Yeah, Jose?
Would you add the exponents?
You do indeed. So I'll have 1/2 to what power then?
It would be, is it 11x, right?
11x.
Plus 2.
Yeah, 11x plus 2, and that's equal to 1/2 power to the question mark. And we're basically done. Because what is question mark? Well, if question mark is 11x plus 2, then these two expressions are equal. The only thing that question mark can be in order for these two sides of the equation to be equal, it can only be the 11x plus 2. And this is kind of tying into a concept that I'm going to be talking about in tomorrow's lesson, where this, well, maybe in Thursday's lesson, I don't even remember when it comes up. But the only way for these to be equal to each other is if question mark must be equal to 11x plus 2. And really, our question mark was a fancy way of saying f of x. So we've solved. The answer here is 11x plus 2. Yeah, what?
I'd just like to point out the time really quickly to you. We only got about like 2 minutes left.
Dang, you are right. I'm going to rush through example number 4. Sorry, guys. I think once we have all the tricks down, hopefully the homework will come to us easier. All right, so this next one is going to be very similar, where I'm going to have a change of base. I want all the bases here to be 7. If this is 7, this is 7, then I can actually combine them. So I'm going to rewrite the numerator here as 7 to the power of 2, that's 49. And the denominator is still the same, 7 to the power of 6x plus 5. that should, I'm trying to somehow get that equal to 7 to the power of, I'll leave it as f of x instead of a question mark in this case. All I've done is rewrite 49 as 7 squared, which therefore turns into 7 to the power of 2x, because when I do a power to the power, I'm multiplying powers, so I still have the same denominator though. 7 to the power of 6x plus 5. Nothing else has changed, 7 to the power of f of x. From here, because I have like bases, I'm going to subtract instead of add. So back here, I was multiplying with same bases. Now I'm going to subtract, and I'm going to be left with, I'll come back up here. This is going to be 7 to the power of 2x, and then minus, the key part here is I'm subtracting both of these two terms, so I have to have parentheses. So minus 6x plus 5, and that should be equal to 7 to the power of f of x. And then the only thing that f of x should be equal to is this thing. Just set their exponents equal to each other and you have the answer. Therefore, f of x is equal to this thing. And I'll go ahead and simplify that. 2x minus 6x is negative 4x, and minus the 5, because this negative sign is distributed as well. It's distributed twice. So minus 5, and we have our final answer. So it was basically like example 3. I just tweaked it a little bit. Question, what?
So I understand how you got the negative 4x, but how did you just get the negative 5? Because wouldn't the 2x affect that too, not just the negative?
So you're saying, what is 2x minus 5? And the answer is, well, that's just minus 5. So
Okay.
essentially what I'm doing is I'm distributing the negative and then I'm combining like terms. I'll have a negative 6x and a minus 5. The negative 6x and the 2x combined to negative 4x, and negative 5 has no other like terms, so I leave it as negative 5.
So just because it has no like terms, it's just negative 5.
Precisely, yeah.
Okay, that's a little confusing, but okay.
All right. So good luck, guys. I I think I covered all the types of problems that you'll see. Do the homework tonight, and I'll see you tomorrow.